In this video, I'm going to talk about using sequences in GeoGebra. In a previous video, we talked about lists. And lists are nice, but if you have a long list of similarly defined objects, it can be tedious to type things out. So to solve this issue, we can use sequences in GeoGebra. And sequences are lists whose elements are defined using a pattern or algorithm. So if we go to our input bar and we start typing sequence, we see that we have some options for sequence. Now, I'll mostly be using this fourth or fifth option, where we give GeoGebra an expression, a variable that we can use in the expression, a starting value for that variable, an ending value for the variable, and then an increment by which we want to increment that variable. So let's look at two examples to show what I mean. I'm going to create a function graph. So we'll do f of x equals e raised to a power of sine of x. Now what we'll do is place points on this graph. I want to place a handful of points on here. So what I'm going to do is I'm going to call my sequence points, and then I'm going to use the sequence command. Now each point on the graph should look like I for the x-coordinate and f of I for the y-coordinate. Now I is this variable I'm using within my sequence, so I need to tell GeoGebra that. And we'll start at 0, and we'll end at I equals 5, and then we'll go in increments of 0.5. Now if I hit enter, we've got this sequence of points all on the graph of f. And like lists, if we click on these points, we can style these points in a consistent manner. So all of the points get styled in the same way. Now a cool thing about this is, even if we change the definition of f, these points are going to adjust accordingly. Okay, let's look at a second example that's a little more sophisticated. I'm going to hide all of my other things. I'm going to create a point C. I'm just going to place C, we'll say 2, 2 right now, but it doesn't matter the location of C. I'm going to define a number, n, which is going to represent a number of arms. I'm going to create spinning arms that spin around this point C. I want 7 of them, so I'm going to do n equals 7. And I want the length of these arms to be 1.5. So I'm going to do r equals 1.5 for the length of these arms. Now, since I want these rotating, I'm going to create a slider named a, and we're going to go from 0 to 2 pi in small increments. Okay, so we've got a center point that we can move around, and slider A is going to control the rotation of these arms. Now to create the arms, I'm going to say arms is equal to sequence. In the elements of the sequence, I want to be segments. So I'm going to use the segment command, and each segment should start at C, and it should end at C plus R times cosine of A plus 2 pi divided by n times I, and then r times sine of a plus 2 pi divided by n times I. Now we want the variable for the sequence to be I, so we'll say I. We want to start at 0 and end at n minus 1. Now if I hit enter, it's going to create the sequence of segments. And these segments always stay centered at C. And as I vary the value of A, these segments are going to rotate accordingly. If I change the value of R, the arms are going to grow in length. So the sequence command is dynamic in that it takes into account all of the variables that you use to define it. And if we increased n to say, I'm going to use a bigger number like 27, now we don't have to type out 27 different commands, because all of our commands would look similar.